Hello, good morning, guys.
Good morning, sir.
So in the last class, we discussed about ping, we discussed about trace route. Okay, we saw about ping, trace route, ICMP, ARP, and ZR. Okay, these are the things we saw yesterday. So ping and trace route, these are the two commands that are used to test the connectivity. Okay, used to test connectivity. Then your ping command, it works on the ICMP protocol, Internet Control Masses protocol. So this is the protocol working in the background. Trace route and ping, these are just the commands. Okay, but in the background, your ICMP protocol is working. Then we have the ARP, Address Resolution Protocol. Okay, so we know that in your LAN networks, entire communication is happening with the help of MAC addresses. Correct. So let's say if we are having two systems connected to a switch, and let's say MAC address is A, MAC address is B, and IP address is, let's say, 10.1 means 192.168.10.1, and this is 10.2. So when I'm trying to ping or test the connectivity from system 1 to system 2, I'll say ping and I'll say 10.0.0.2. Okay, so ICMP packet will be generated with the source IP, destination IP, source MAC, and destination MAC information. Source IP will be system A IP, that is 10.1. Destination IP will be 10.2 provided in the ping command. Source MAC will be MAC address of system A, but system A would not be knowing the MAC address of system B. So how do we get the MAC address? So for that purpose, a new packet will be generated, and that will be your ARP packet. Your ARP packet or the ARP protocol is this protocol that is going to provide you or resolve the IP address into MAC address. If you know the IP address, it is going to get you the MAC address. Okay. So ARP is going to work. ARP is broadcast packet. Your ARP is a broadcast packet. So again, this is going to have the information source IP, destination IP, source MAC, and destination MAC. Source IP again 10.1, destination 10.2, source MAC A, and destination MAC as all Fs. Why? Because it is a broadcast packet. Now this packet is complete. This packet is going to travel. Okay. Then your switch is going to make an entry in the CAM table, and then it is going to broadcast it. So it packet will reach here. Then your system 2 is going to reply with the required information, means the MAC address. And then again, your switch is going to record the MAC address of your system 2, and it is going to forward it back to system 1. And this is how it is going to bring you the MAC address. Clear? Then we have one more concept, ZR, gracious ARP. Okay. So your ZR, it is used to announce, first of all, there are certain purpose for redundancy. Okay. If you remember, for duplication, to check duplication. Let's say you want to check whether the same IP address is being used in the network or not. So you'll be generating a ZR. Or if your IP to MAC binding information changed, IP to MAC mapping information is changed, means before your IP address was something else, but now your IP address is changed. So before accepting the IP address, you are going to check whether the same IP is used in the network. Okay. So these are the informations we saw yesterday. Today we'll be going with the default gateway, proxy, ARP, Telnet, and SSH. Okay. Before going to these concepts, we'll be discussing about some basic commands of your router, so we can start working on the routers. Okay. So for that purpose, I'll just open the Cisco Packet Tracer, and today onwards our lab starts. Okay. So I'll just take one router and let me directly connect it with one PC. Let's say I want to assign the IP 192.168.10.1, 192.168.10.2. Okay. So everybody knows how to assign the IP in the router. Okay. All you have to do, just go to the interface. How you're going to check the interface? Here you're going to see the name of the interface. It is Z0 by 0. Okay. So just go to the router. No. Then enable configure terminal, global configuration mode. In the global configuration mode, go to the interface Z0 by 0. Then assign the IP address 192.168.10.1 and subnet mask 255.255.255.0. Now let's say you don't know, you know the command IP address, but you don't know what is coming next. So just press the question mark, and it is going to tell you that you have to provide what? IP address. Okay. So I'll assign the IP address 192.168.10.1. After IP address, what is there? So again, question mark, and you'll see it is saying IP subnet mask. So you have to provide the subnet mask information. 255.255.255.0. And now if you see this CR means it is creating return. Now you can hit enter. Until or unless you see this CR, you cannot complete the command. Okay. If I try to complete the command before this, it is going to give me an error, incomplete command. Okay. And then you can use upper arrow keys to switch between the commands. Let's say whatever commands you have executed in before, if you want to use the same command, you can just go and use the upper arrow key and down arrow key. Okay. So subnet mask information. This is clear. Now let's say your cursor is at the end of the command, but you have to add something in the beginning, because usually when we are like removing a command, we are just saying no in front of that command. Okay. So all you have to do is press Control A, and your cursor is going to go at the beginning. Okay. And to go back to the end, Control E. Control A is the beginning, Control E is the end. Okay. So this is how you can switch. Otherwise, what you have to do, you'll have to use the arrow keys and wait until it comes to the starting and ending. Okay. Your mouse is not going to work. If you say in the mouse, it is not going to work. Okay. Because this is CLI, and in CLIs, in the real CLIs, your mouse is not going to work. Okay. See, like according to this, it is here where it is typing in the beginning. Okay. So Control A and Control E. Hit enter. IP taken. Now we have to say no shutdown, or in short, no shut. And hit enter, and your interface is up. You can see it is green. Okay, we have assigned the IP addresses. All right. Now what we are going to do, I'll assign the IP address in the PC. That is 192.168.10.2. Clear? Now test the connectivity from PC to router. Having the connectivity, clear? Okay, now we'll see the basic command of your router. So first of all, we'll be seeing your privilege mode commands. Which mode is this? User execution mode. This is user execution mode. If you want to move to the privilege mode, what is the command? Enable command. Hit enter. Now in this mode, you are having a lot of commands. Okay. But for basic functioning to start working, I have already made some commands here. Okay. Like you can set the clock, date and time. Okay. So if you want to check your date and time of your router, simple command is show clock. If you want to check the date and time of your router, then the command is show clock. Hit enter, and it is going to show you the date and time. Okay. That this is the time within milliseconds. Then what is the day and date? Everything. Right now the date is 1993. Okay. So what we are going to do, we are going to change this date. How you can change? You can say clock set. Okay. Then you have to give the time first. So what is the time? Right now, let's say 8:25. So I'll say 8:25, and seconds I'll give 00. If you don't know how to give the date, next thing is press question mark, and it is going to tell you, give the hours, then the minutes and the seconds. So let's say I'll say this is 8:26 and seconds 00. Now what is next? You have to provide the day, means the date. So date today is 17. Then you have to provide the month. The month is November, correct? And what is the year? 2022. Hit enter. This is set. Again check show clock. This is clear. How you can check the date and time, and how you can set the date and time. This is clear, right? All right. So next we have configure terminal command to go to the global configuration mode. Okay. Then there's one more command, copy running configuration to startup configuration. Okay. So for that purpose, first of all, we have two types of configuration. One is the running configuration, and second is the startup configuration. The running configuration is stored where? RAM. All your running configuration, whatever configuration is running in your router, that is stored in the RAM. And if you want to check your running configuration, you have to give the command show running config. This is the command. If you want to check your running configuration, whatever configuration is running in your router, then you have to give the command show running configuration. Okay. Or in short, this is the complete command, and in short, we'll give show run. Okay. So this is the complete command. Hit enter. This is going to provide you that the current configuration size is 705 bytes. This is the version of your iOS, and these are certain configurations about all the, like our interface is having the IP and all. Correct. These are the configurations. This is the running configuration. What about startup configuration? Where it is stored? ROM. NVRAM. Running configuration in the RAM and startup configuration in the NVRAM. Because RAM is volatile. Your RAM is volatile, so it cannot store data without power. So we need the NVRAM to store the configuration. Okay. So you're going to say show startup configuration. Okay, one more thing here. I'll say show, and instead of typing everything, I'll just hit tab. And it is going to auto-complete the command. So tab is going to help you to auto-complete the command. But it is not going to work until or unless there is a unique, match. Like if there is some other command with STA, starting with STA, then it is not going to work. But as soon as I say STAR, then it will be unique startup config. And if you want to check what is the STA command, one more command. So there is show standby and show startup config. There's two commands. So this is why it is not going to show you anything. Once you say STAR, this will become unique. So it is going to auto-complete the command. Okay. So show startup config. If you hit enter, it is going to say startup configuration is not present, because startup configuration is permanent. Like one is your RAM in your system. Do you copy the data in the RAM? We do not copy. But what about your hard disk? Your data will not be stored in your hard disk until or unless you manually copy it or you move it there. Okay. Why? Because that is a permanent storage and your RAM is a temporary storage. Same way, your startup configuration will not be created until or unless you give a command to create it, until or unless you manually create this. Okay. How you can create? So either you can say copy, and you want to copy the running configuration into the startup configuration. This is the command that you want to copy the running configuration into the startup configuration. So right now, when I checked, it was saying startup configuration is not present. And if I hit enter now, it is asking, is the destination file name correct? Startup configuration? Yes, it is correct. If you want to change, you can give a new name. Okay. But again, your router is just going to check the startup configuration. So we need the same name. So I'll just hit enter and default. See, it has created the configuration and return status is okay. Now, if you check, so before when I gave the command show startup config, I was having startup configuration is not present. And now if I check again, show startup config, I'm having the configuration. Correct? Is it clear? Clear, right? And you can see entire same configuration is there. The interface is having the IP and so it is simply the backup of your running configuration. So that when your router restarts, your router can pick up the configuration from the startup configuration and it can copy in the running configuration so that your router can function properly. Okay. So that you don't have to do the configuration again and again every day. This is clear? Okay. So copy running configuration to startup configuration, show running config, startup config. This is clear. Now let's say you want to delete your startup configuration. Right now we are having startup configuration, right? We have the configuration. If you want to delete this configuration, simple command is erase startup config. Okay, then it is going to ask you for confirmation. If you give the confirmation, it is going to be removed. See, erase of NVRAM is completed, means your NVRAM has been cleared. And now if you check again, show startup configuration is not present. Clear? Okay. Then next we have the ping command. If you want to ping, let's say if I want to check connectivity with the PC, so I'll say ping 192.168.10.2 and I can check the connectivity. Clear? After this, we have show IP interface brief and reload command. The reload command, okay, the reload command is going to restart your router. If you want to restart your router and you don't want to go to the button itself, then you can just give in the reload command and hit enter and your router will restart. So before restarting the router, did we have startup configuration? No, we raised it. So means whatever IP address I assigned to the router, that has been cleared because the configuration was in the RAM only, not in the NVRAM. And this is the reason you see this system configuration dialog again. If you have any simple configuration in your router, any single configuration in your router, you're not going to see this thing again. Okay, check. So let's say I want to check whether what are the IP address, if there is some IP address on my router or not. So I'll say show IP interface brief. Okay. If I hit enter, it is going to say on all the interfaces, there is no IP address assigned. Okay. So we are going to go to the global configuration mode, interface is 0 by 0, IP address 192.168.10.1, 255.255.255.0. Then no shutdown. This is clear. interface is up. So we have some configuration, right? Now we have an IP address on a router. Let me exit. And if I say copy running config to startup config, this is a big command. So in short, we can say copy running to startup. That's it. Okay. Or even shorter, there's an alternative for this command. You can say the write command. This is going to work the same. This is going to do the same task as your copy running configuration to startup configuration. Your write command is going to write your RAM contents into NVRAM. Okay. And again, more short, you can just go with the WR. Okay. If I hit enter, configuration is built. Now, if I check show startup configuration, and you can see I have the configuration. In the configuration, I have an IP address on my router. Okay. And if I try to reload now, give the reload. Did we see the system configuration dialog? No. Why? Because we had some configuration. Okay. And because we had your NVRAM, we had configuration in the NVRAM. So the router has already loaded that configuration. Check show IP interface brief. Interface. And this time you can see we are having the IP address. This is clear. Then trace route command we have already discussed in the last class, that it is going to bring you the number of hops. Okay. So in router, it is going to work trace route. But in case of PCs, like your Windows PC, it is going to work trace RT. Okay. So these are some your privilege mode commands. Okay. For basic functioning, so that we can check the IP addresses, we can check the configurations. Okay. And we can take the backup of the configurations. Right now, we have taken backup in the NVRAM only. We haven't taken backup on the servers. Okay. I'll be telling you about how to take the backups on the servers as well. We'll be seeing that. So these are clear. Any doubt with these commands, privilege mode commands? Online people?
No.
Okay.
No, sir.
So next we'll be seeing about global configuration mode commands. Okay. Now we are in the global configuration mode. Now let's say I want to set some password on my router. So there are two types of password I can set. One command is the enable password. Okay. And let's say you don't want to use a command, you just want to type it, and you can comment it by using exclamation mark in the beginning. See, not executed. Okay. One command is your enable password, and the second command is your enable secret. These are the two commands. So your enable password command, it is setting up a plain text password. Okay. It is setting a plain text password, and your enable secret, it will set an encrypted password on your router. Okay. So let's see. I'll say enable password, and whatever password I want to apply. Let's say I want to apply password 123 on my router. So I have created the password. Now this password is applied on my privilege mode. Okay, means when I will try to go from your user execution mode to the privilege mode. So before going into the privilege mode, I'll be asked for password. Okay, so check. If I say disable, which mode is this? User execution mode. If I say enable, before going to the privilege mode, I'll be asked for the password. What is the password? 123. So I'll say 123. Password will not be visible in your router. Okay. Hit enter. But there is a problem with this password. What is the problem? If you say show running config, very clear. This is a clear text password. Okay. So it is easily available or easily visible. So let's say you are working in your router. You have taken the access of the router and you have gone for a cup of tea or something else. And somebody is coming from the back, checked your router. They know the password. Now they can take the access. Correct. So for this purpose, what you can do, go to the global configuration mode. Okay. And then given the command, enable secret and whatever password, let's say 456, you want to set. Hit enter. Now, two passwords we have set. One is the enable password and one is the enable secret. So when your router is having both of the passwords, your router is going to prefer your secret password. Your enable password is not going to work. Okay. So if I exit right now and say disable user execution mode, I'll say enable command. Now, if I give the 123 password, see, it is not working. It is saying bad secrets. Okay. If I try again with the 456, I'm able to use. And if I check in the configuration, if I say show running config, my 456 password is very clear. Okay, it is in the encrypted form, means not an understandable form. So if somebody is seeing this also, not able to understand that it is a 456 password. Clear?
But it will show 1, 2, 3 as.
Yes.
No, enable password is showing as 1, 2, 3, but you kept on 4, 5, 6, but it will be on secret, right?
Yeah, on the secret.
Encrypted.
Yes,
Okay.
this is encrypted. So you just have to set only one password, because if you set both of them, again, your secret is going to prefer your enable password is useless. Okay, this is of no use. Clear? All right. Now let's say you have set enable password. You have set the plain text password. Now you don't want to set, like, there are multiple passwords in your router that are plain text. Okay, so all the passwords you are not willing to change. So you can give one command and all your plain text password will be encrypted. How? The command is service password encryption. If you give this command, all your plain text password in your router, they will get encrypted. Hit enter. Okay, now go to the show running config again. Check your 1, 2, 3 password. Encrypted, right? So this is how you can secure your router. Okay, this is how you can secure the local access to your router using local passwords. Clear? If you want to remove the password, so for setting up the password, enable password, we gave the command enable password. Okay, now I want to remove this password. So I'll just go in the beginning, say no, and hit enter. That's it. Any command in your router you want to reverse or undo, you just say no in front. You just append a no in front of the command, and that command is negative, means removed. So now if I go and check, show running config, I'm not having it. Clear? But right now, you see, for checking of the configuration, I have to go to the privilege mode again and again. For checking the configuration, I have to go to the privilege mode again and again. So what you can do, you can just remain in the global configuration mode. For checking the configuration, what is the command? Show running config, correct? This is the command. But if I try to run it, this command in the global configuration mode, it is saying invalid input detected, because your privilege mode commands, they are not going to work in the global configuration mode. So if you want to use your privilege mode commands in your global configuration mode, you just append a do. Okay, you just append a do in front of the command, and you'll see you are having the output. Clear? Clear, right? Okay.
Once again, like, what if we only forgot the password? So how can we?
Yes, we can crack the password. We have the mechanisms. I'll be showing you. Okay, I'll be showing you how you can crack the password. But these are beyond the topics, so we'll need some extra time for that. So any day, if we are having like a small session, so that day we'll be doing all these tasks, like your backup and restore of your router, as well as the password breaking and all. Okay, because these things happens. Like, it is not important that you forget the password. Maybe you are going in a company, and in that company there was a network engineer before. He set up the password and he's not available, and nobody in the company knows the password. So how are you going to do it? So there are two things. Either you can flush out the configuration. This is the one way. The second way, you can save the configuration and still change the password. Okay, so both of the ways we'll see. Okay, so we have seen the service password encryption, and do also we have seen. Okay, now next what we can do, we can set the host name of the router. So by default, the host name of the router will be router. And if you want to change, you can just give in the command host name R1, and that's it. It's changed. Clear? Once you have done with all the configuration, always give the command write, so that you will have the backup. And again, this write command, it is a privilege mode command. If I want to use in the global configuration mode, I'll say do write, and in more short, I'll say that's it. Clear? So these are some basic commands we are going to use. This is clear to everyone, online people?
Yes.
Okay. So now we can move on with our topic today. Default gateway, proxy, ARP, Telnet, and SSH. So what is a default gateway, guys? Okay. Doorway. Anyone else? Network IP. Network IP is not the default gateway. Exit point. Your gateway is the exit point of the network. Let's say this is the class. This is our class. Okay. And there are certain students sitting in the class. So if they want to communicate within the class, do they need a gate? No, right? But let's say they want to talk to some other class outside this. Outside our class, so our class is having a gate. So they'll go through this gate, then they'll talk to some other persons. Clear? So your default gateway is the exit point. Okay, or you can say the last place or the last address of your network through which your data is going to exit your network. Okay, let's say again, example, take a router, 2 switches. We are having some systems connected. This side we are having 192.168.10.0, and this side we are having 20.0. Okay, and on router we are having the IPs .1 and let's say .10 and .20, again .10 and .20. So if I want to talk within my network, I don't need to go to the router. Why? Because my switch is going to facilitate communication with the ALTO MAC addresses. But when I want to ping in the 20.0 network, your switch is not going to have the information. Okay, so we need a way or a place to exit this network. So how do we exit this network? So if you see, if I want to exit this network, so what is the last place? This one. After this place, I'll be having new network. So this is the last address I'll find when I'm trying to exit my network. So this will be your default gateway. So your default gateway is the last address of your network through which you are going to exit the network. Okay. Or simply in general cases, you will say the IP of your router. Your router IP is the default gateway. Because again, if you are using a router, your router is going to provide communication between 2 different networks. So ultimately, if you are having IP on the router, that is your default gateway, and that IP is going to help you exit the network. Okay. Now see. So if you understand about default gateway is used for communication to the other network host. Means when you want to communicate with host in some other network. Okay. So let's go to the packet tracer. This is one network this side. And let me take one more host. This side will be using the 20.0 network. So 192.168.20.0/24. And this side we are using 192.168.10.0/24. The IP on the router from the 20 side is 192.168.20.1, 192.168.20.2. Okay. So on one side we have assigned the IP, on the second side we have to assign the IP. So I'll go to the router interface Z0/1. I have to assign with the IP 20.1. So I'll go to the interface Z0/1. I'll say IP address 192.168.20.1, 255.255.255.0, and I'll say no shutdown. Interface is up. Assign the IP in the PC 192.168.20.2. So what will be the default gateway for this PC? Let's say if your PC wants to talk to 10.2, so it has to exit its own network because 10.2 is not available in this network. So how it is going to exit? Through the router. And what is the router IP? 20.1. So this is going to be your default gateway. Similarly, for this PC, what is the gateway? 10.1. Okay.
Two gateways in the router IP, then this particular router is having 2 IPs.
Yes. So default gateway is the IP of your own network. For this PC, in which network this PC is there? 10.0 network. So the default gateway will be 10 IP. This side we are having 20. So the default gateway for 20.0 network will be 20.1. Because if you see, the packets are going to travel like this, right? So they are going to find this IP. And if they are traveling from this side, they are going to find this IP. Okay. So this will be IP from the same network only. Because again, if default gateway is of the different network, then there is no way to reach it.
There are 10 networks and 3 are 10 IPs.
Yes, 10 default gateway. Okay. But routers, they will usually be having 2 interfaces, 3 interfaces, 4 interfaces like that. Okay. All right. This is clear. Default gateway. So now I can ping. I can have connectivity from 20.2 also. So there will be a process. The first packet will be dropped and the remaining 3 packets, they will be successful. Okay. And this first packet drop, this explains your next concept. That is your proxy ARP. That is your proxy ARP. So what is happening in the background? Understand. Okay. Next concept is our proxy ARP. So if we consider your PC is going to have ARP cache. In the ARP cache, it is going to have the information IP and MAC. Correct? IP and MAC information. Similarly, this PC is going to have the information IP and MAC. And your router is also going to have an ARP cache. So in your router also, let's say IP and MAC. These are the three informations, three databases for each and every devices. Initially, PC1 will not be knowing about any of these, correct? Similarly, PC2 is also not knowing about. This is PC1, PC2. They do not know about each other. Even your router doesn't know about these. Okay. So when I'm giving the command, let me change the color. When I'm giving the command ping 192.168.10.20.2 means this is in the different network. So first thing, your PC will understand that this particular IP is in the different network. So first of all, it is going to generate ICMP packet. It is going to generate an ICMP packet with the source IP, destination IP, source MAC, and destination MAC. Source IP is 10.2, destination is 20.2, source MAC, let's say A, destination MAC, do not know. Why? There's no entry in the ARP cache. Correct? So if we do not know the destination MAC, then next packet will be ARP. ARP will be generated, right? So let's say a new packet ARP has been generated. So first of all, if you see this particular IP 20.2 is in different network, means I cannot directly reach this. I cannot directly reach this. I'll have to go to the default gateway. Default gateway information we have provided in the PC. We have set IP address, subnet mask, and default gateway. So it knows the IP of your default gateway, but MAC address do not know. Again, so it is going to generate an ARP request for your 10.1 MAC address. Then source IP, destination IP, source MAC, and destination. Or let me just directly give you the practical so we will understand in the live session. I'll go to the simulation mode. Before going to the simulation mode, let me check the ARP cache of these devices. Okay, so ARP-A, having the ARP cache. So I'll just delete this on this PC. Okay. Okay, delete it on your router. Show ARP, having the ARP entry. So to remove this ARP, I can say clear ARP cache. Check again. Still not clear. So sometimes it is going to happen that you give the command clear ARP cache and the ARP cache is not going to clear. So what you can do, you can just see the interfaces, shut down these interfaces, and then no shutdown again, and it will be gone. Okay. So I'll just go to the interfaces. Interface Z0/0, shut, and then no shut. Interface Z0/1, shut down, and then no shutdown. Now if I go and check, show ARP. So only two entries. These are for its own addresses, 10.1 and 20.1. Okay, self entries your router knows, but now it doesn't know about the PCs. Okay, sometimes it is going to happen that the clear ARP cache command is not going to clear your ARP cache, so you can just shut down the interfaces and no shut down them. Now let's go to the simulation mode. I'll go to the PC command prompt, and then I'll try to ping 20.2. So again, two packets have been generated. One is your ICMP and second is your ARP. Open the ICMP packet. So source is 10.2 and destination is 20. Correct? Or let me do one more thing. Is it completed the ping? Okay, let me delete once again, because I'll change the MAC addresses so we can understand easily. Interface Z0/0, shutdown, no shutdown. Interface Z0/1, shutdown, no shutdown. Check the ARP cache, show ARP. Okay, only two entries. Now it is clear. So let me just change the MAC address first. So PC1 will be all zeros and 1. And PC2 will be all zeros and 2. So that when we see the MAC address in the tables, we can understand. Okay. Now let me generate the packet. So two packets have been generated. One is your ICMP and second is your ARP. If you see the ICMP packet, the source is 10.2 and destination is 20.2, but there is no layer 2 information because we do not know about the MAC address of your PC2, right? And you can read the details here also. Under here, it is going to say all the details. So the ping process start the next ping request. Ping process create ICMP echo request message and send it to the lower process. Then the source IP address is not specified. The device set it's to the port IP address, means this is the port IP address. Then the destination IP address 192.168.20.2 is not in the same subnet and is not in the broadcast address. Means it is neither the broadcast address, not in the same network. So what we have to do, the default gateway is set, the device set the next hop to default gateway, means it is going to deliver this information to the default gateway. Okay. Then we have the ARP packet. If you see this ARP packet, it is going from 10.2 to 10.1, your default gateway. Okay. And if you see outbound video details, the source address is 10.2 and going to the router 10.1. Okay. Now what is going to happen? This is going to travel here. Your ARP packet traveled. Now your router is going to reply. Your router is going to reply with the ARP reply. Okay, and it is going to provide its own MAC address. That is 7C01. Okay, 0006 to ACB 7C01. So just understand 7C01. Okay. So as soon as this ARP reaches your PC, it is going to have the address in the ARP cache. Correct. Now we have the information about the default gateway. Correct. But again, if you see here, what is happening? This packet is going from PC1 to the router. If you see, who is the source? Who is the source? PC. Who is the destination? Again, PC. But if you check the MAC addresses, who is the source MAC? Who is the destination MAC? So what is happening actually here? Your router, it is acting as a proxy. Your router, it is acting as a proxy. How? From 10.2, we want to travel to 20.2. So we need the MAC address of 20.2. But your router, it is a layer 3 device. It is not going to forward your layer 2 information. So what it is saying that, okay, you give the packet to me and I'll deliver it. Means your router is acting on the behalf of your PC2. So here in the packet, we are having source IP as 10.1, sorry, 10.2. Destination IP we are having 20.2. Source MAC we are having for the PC, that is A, or let's say all zeros and ones. But destination MAC, that is your router. So according to the Ethernet network, because in your LAN networks, again, entire communication is based on the MAC address. So your LAN in the LAN, it is something like, okay, the MAC address of 20.2 is your router MAC address, because your router is acting as a proxy. It is providing its own MAC address for 20.2. Okay. So your PC, it is going to consider if I want to send packet to 20.2, I'll use this MAC address only. Why? Because your router is acting as a proxy. So what is going to happen? Now this packet is going to travel to the router. Okay. But does the router know about PC2? No. So it is going to drop this packet that I don't know about this packet. So this is the reason your first packet is going to drop. Then instantly your router is going to generate a ARP request this side. It is going to generate a ARP request this side and it is going to get the MAC address of PC2. And when the next, because your PC is going to send 4 packets, right? One is dropped. When the next packet arrives, what is going to happen? Your router is going to change here. Like in the packet, it will be like source IP, destination IP, source MAC and destination MAC. So this is going to be received by the router. Source IP will be 10.2, destination will be 20.2, source MAC will be all zeros and 1, and destination MAC will be the router 7C01. Correct? Now, when your router is forwarding this packet this side, the ICMP packet, what it is going to do? It is going to say source IP, destination IP, source MAC, and destination MAC. Okay. Then what is going to happen? Source IP will be again same 10.2, destination IP 20.2, but your router is going to change the source MAC. It will say I'm 7C02, the MAC address of this interface, and the destination will be 0002. Now, when this packet is reaching your PC is going to note all these details that 10.2 is having the MAC address, because they will take the information only from the packet, right? So it is going to note that, okay, 10.2 is having the MAC address 7C02. So according to this PC, what is the MAC address of 10.2? 7C02. So in between, your router is acting as a proxy. So whenever your hosts are separated by router, then proxy ARP will be in use. Okay, and by default on your router interfaces, proxy ARP is enabled. If you disable the proxy ARP, there will be no communication. There will be no communication. This is clear, the theory part. See the practical. So this is the ICMP packet. having the information, source IP 10.2, destination IP 20.2. Source MAC is your route PC and destination MAC is your router. Packet going to the router. See, your router instantly generated ARP and it dropped this packet. This ARP is going for the 20.2. It is going to get the MAC address of 20.2. So this first packet is dropped. Now your PC is going to respond. Router has the MAC address of PC2. Now when the next packet arrives, what is going to happen? Check. The same information will be there. Source IP 10.2, destination IP 20.2, and source is 0001 and destination is router. Now if you compare this information here, see, source IP same, destination IP incoming and outgoing both same. Source MAC, do you see? Router changed. Router has changed the source MAC and destination MAC again changed. So from here we sent from PC1 to the router, and here your router is changing from PC2. So in between your router is acting as a proxy. This is something like, let's say I want to deliver a letter to my friend. So I'll be delivering the letter to the post office. Correct? I will be delivering my letter. I will be giving my letter to the postal service. And now they are responsible for delivering that packet. Correct? So this router is acting as a proxy or the postal service. Clear? Now, if your friend has to send a reply.
Router address will set automatically that 7C01.
This is the MAC address actually. MAC address of router interfaces. On this side, it is 7C01. And on the other side, it is 7C02. If it was some other MAC address, it would show some other MAC address. See, each and every interface of your router has some MAC address. Let me show you. Go to the router and you can check the information. Show interface, and whichever interface, let's say you want to see Z0 by 0. So this is the MAC address of your Z0 by 0 interface. 7C01 you can see. And the second side interface, that is Z0 by 1, that is having 7C0. So this is just the MAC addresses of your router interfaces. So now this packet is going to travel to PC2 and PC2 is going to reply just to the router. See, according to PC2, what is happening? Source is itself, destination is the PC1. But again, according to the LAN information, MAC address information, the MAC address source is PC2, but destination is router. Means these both are just going to deliver the information to the router, and router is going to provide the communication. So this is how your proxy ARP works. Means we want to go from 10 to 20, but your router is saying, okay, I'm 20. Clear? Now read the theory. Proxy ARP is used to facilitate ARP exchange in order to resolve IP address to MAC address in devices that are separated by routers in the same network or subnetwork. If we are having devices that are separated by router, then we are going to need proxy ARP. So router cannot forward layer 2 packets. Hence, ARP messages are never propagated outside of their network because they are layer 2. Then when a device wants to resolve the MAC address of another device in a different subnet, the router located in between two subnet act as a proxy for the other device and respond to the ARP broadcast with its own MAC address. Whenever we are sending the ARP, router is going to say, this is my MAC address. Whenever some other device is sending ARP request, your router is going to say, I am the other network. So entire communication will be facilitated by the router. And this router is in between is acting as a proxy. So this is the reason this particular type of ARP is known as a proxy ARP. Because instead of getting actual MAC address, we are getting some other MAC address. Clear? So proxy ARP clear, guys? Online people? Now we have two remote access protocols. That is, one is your Telnet and second is your SSH. Okay. So we'll be seeing about them. So why do we need these remote access protocols? To remotely access your device. Okay, let's say every time you don't want to use the console cable and access the router and do the configuration. Once you do the initial configuration, you'll access the router through the Telnet protocol or SSH protocol, and then you'll access the router from anywhere in your network. You'll sit anywhere in your network and you can access it just through the IP. Okay. So we are having two protocols. First of all, let's see practical and then we'll go for the theory part. So for this purpose, I'll take one router, or let's just use the same topology only. Okay, so this is the router. Now I want to access this router because for right now, if I want to access this router, I'll have to just go to the CLI. I'll have to open the router and go to the CLI. In real scenario, you'll not be having something called as CLI. Okay, these options like physical config, you will not be having this. You just connect the console cable and you'll directly having a black screen and with some text, and you'll have to execute the commands. Okay, there will be no concept like this config and all. There's no concept. Today we'll be seeing that. Okay, I want to access the router. So we have two protocols. One is your Telnet and second is your SSH. Difference, your Telnet is less secure, or you can say insecure. Why? Because entire communication in your Telnet is in plain text. Okay, and in your SSH, the entire communication is encrypted. Means no one will be able to see your data, whatever communication you're doing. Clear? First, we'll do the practical and then we'll see the theory part. So if you want to configure Telnet on your router, okay, then you have to configure virtual terminal lines. Virtual terminal lines. Okay, so you have to give in the command line VTY, virtual teletype. Okay, means these lines are going to provide you the access to the virtual terminal, because physical terminal is in the router. You are taking access virtually from a remote place. Okay, so let's go and directly do this. How you are going to configure. So go to the global configuration mode. There you have to say line VTY. Okay, then line numbers, they are ranging from 0 to 15. So total 16 lines are there. Means at a time, 16 users can access your router remotely. At a time, 16 users can access your router remotely. So first of all, you will have to give the first line number. So we will start from 0 because the starting number is 0. Now, depending on how many number of users you want to allow to take the access at the same time, depending on that, you have to decide the last. Let's say you say 0 and 1 means only 2 lines you have given. So 2 users will be able to access at the same time. If you have given 0 to 2, so 0, 1 and 2 will be having the access. And if you have given 0 to 15, all 16 users will be having the access. So let's say right now we are having 2 systems. So I'll just provide access to 1. So I'll say 0 to 0. It's only 1 line. Hit enter. Okay, we cannot give 0. Minimum 2. Okay. Clear? Now just set in the password. What is the password you want to set? Let's say I want to set the password 123. Hit enter and give the command login. Means log in the virtual terminal lines using this password. So your router is going to allow the login. Now how you can access? Go to the PC. See, we have configured Telnet, but we haven't configured any sort of IP address. Means these both IP address we can access. I mean, you can access the Telnet through both of these IP addresses. Okay, just go to the system. And then right now I'm in the computer C drive. If I say Telnet and 192.168.10.1, what it is asking? Password. We set some password there. What was the password? 123. If I say 123 and hit enter, is it my router? Now you can execute all the commands. Enable. It is asking for password 123. 456 is the password. You can say config T. You see, it is my complete router, right? I can say show IP interface brief. So I'm having the IP on the router 10.1 and 20.1. Now I can do all the configurations. Clear? This is clear. Similarly, your second system will also be able to access using this IP 20.1. So if I say Telnet 192.168.20.1, same thing. Given the password 123, router is there, enable, given the password, and now you can check show IP interface brief. Okay. If you want to check how many users are taking the access, you can give the command show users. So right now you can see how many users are taking the access. So 2 users are taking the access. One is the 10.2 and 20.2. So you can check also. Clear? So this is how you configure Telnet. But this time we just have configured a password and we are able to log in the router. If you want to make it more secure, you'll have to use usernames and passwords. Okay. So how you can use usernames and password? So first of all, I'll just remove this login command. So I'll say no login, and I'll remove the password also. I'll say no password. Okay. I'll exit this. Now in the global configuration mode, we are going to create a user. So I'll say username. Let's say CCNA. Okay. And password I'll configure Cisco. Done. Now again, go back to the lines. So line VTY 0 to 1. Then This time we don't need to configure the password. Why? Because we all have already created a username and password. But we have to say that login using local database. Before, when we set the password, we just said login. But right now when we are logging in through the local database, we have to say login local database. Enter. This is done. Now this time if you try to access, right now in the router, exit. So connection is closed. Back to the system. If I say telnet 192.168.10.1, hit enter. Oh, telnet. Asking for username. What was the username? CCNA. Hit enter. Password was Cisco. We are in the router. Okay. So like this, you can configure username and password and you can access your router. Now, one more thing, your telnet is not secure. Correct. We saw that your telnet is not secure. So we are going to capture packets and we are going to see how your telnet is not secure. So for this purpose, instead of seeing all the packets, I'll just see telnet information. So now we'll see. I go to the PC. Okay, already in there. Let me go once real time. Okay, right now I'm in the system. So now we'll see that your telnet is doing all the communication in the plain text. Okay. I'll say telnet 192.168.10.1. It is trying to connect. Okay. What type of packet is this? Telnet packet. See the telnet data. It is going to say user access verification and asking for username. And once this packet reaches your PC, in your PC, you are going to see the same thing. Okay. Now let's say I'm typing the password. So I'll say my username is CCNA. So do you see some packets have been generated this side? Okay, some packets have been generated. So if I read these packets, if I open the information of these packets, C, then C, N, T. So like this, anyone is able to read what is your username, what is your passwords and everything. Why? Because your telnet is not secure. It is doing all the communication in the plain text. This is clear. So understood? Yes.
To capture the same data in real time.
Yes, we can capture. We have certain softwares like your Wireshark. Okay, we can capture.
So let's say if I want to connect to 20.1 using 10.2, can we do it?
No, only the same network.
Oh.
Okay. Let's say you are trying to say telnet 192.168.20.1. This is what you're trying to say. Okay, you can do that. I didn't know that, but you can do that. Clear? All right.
I don't want to, communicate 10.2 to, don't want to take the telnet from 10.2 to 20.2.
No, this is nothing. There's nothing like this because this particular network is also going to access. And in telnet configuration, we do not set any kind of IP address and all these things. So we cannot do that. Okay. All right. So this is clear about telnet. Sure. Next, let's see the theory about telnet, and then we'll see SSH practical. So your telnet stands for terminal network. It is used as a standard TCP/IP protocol for virtual terminal service given by the ISO. Computer which start the connection is known as the local computer, the system through which we are taking the access. Computer which is being accessed or connected to, which accept the connection, is known as the remote computer. And that's why we say we are taking the remote access. When connection is established between local and remote computer during telnet operation, whatever that is being performed on the remote computer will be displayed on the local computer. Okay, like kind of you can say remote desktop, and not remote desktop, but you can say like your any desk thing. Whatever is being performed on the same next system, we can see what is happening. Same way, if you are doing some configuration on the telnet, okay, so same configuration will be displayed in the router. Telnet operate on client server principle. Local computer uses telnet client program. Okay, because in real scenario, what is going to happen in the router, we are going to configure telnet, but in your Windows, right now in your Windows, telnet is built in by default. Okay, see, So it is built in by default, but not enabled. So to enable it, you can go to the turn Windows features on or off, and there you'll see you have the option of Telnet client. So you have to enable this thing. So it is built in already in your Windows. And if you are not using this, let's say you don't want to enable this, you can use a program. You can use a software that is your Putty software. Okay. You can use this software to take the access. So your client systems, they are always going to use some kind of client program, and the remote computers uses Telnet server program. We configure Telnet server on the router, and that's why we are able to access the router. Clear? Then there are some points about the Telnet. So what are the points? Telnet is an application layer protocol and allows the user to connect to an account on another remote machine, means remote access. Then it uses port number 23. Okay, and mainly designed for LAN networks. Why LAN networks? Because if you try to access in the WAN, then any hacker would able to sniff your data. What is the username? What is the password? Okay, so LAN network is fine because LAN is your trusted network. So in LAN network, you can use the Telnet, but still in the LAN network also, maybe there is a person who is sniffing the data, who is taking the usernames and passwords. So you will go always, mostly in the cases with the SSH. Then Telnet is standard TCP/IP protocol for virtual terminal service, transfer data in plain text. Now your Telnet is vulnerable to security attacks because it is doing communication in plain text. So anyone sniffing your data, monitoring your network traffic will be able to capture all your usernames and password and what are the commands you are executing. No privileges are provided for the user's authentication. Okay, simple username and password you give and you're able to access, or even a simple password you give, you're able to access. Okay, required low bandwidth users. Why? Because not really secure. Okay, not having a lot of features. It is used in Linux and Windows operating system and also on your routers. Okay. Now next we'll see about SSH. So SSH stands for secure shell. SSH is a secure protocol. Okay. So let's see the theory and then we'll go for the practical. So your SSH, secure shell, is a cryptographic network protocol. Means it is going to encrypt your traffic for operating network services securely over unsecured networks. So if you are going through an unsecure network, you can have the communication with the help of SSH. Typical application include remote command line, login, remote command execution. Okay, you can take the remote command line access, you can log in remote command line, and you can execute commands remotely with the help of SSH. But any network service can be secured by SSH. Means even you can transfer files with your SSH. SSH provides a secure channel over unsecure network by using a client-server architecture. Again, there will be a client and there will be a server. Okay. Connecting an SSH client application with a server, similar to Telnet only, because your SSH, it was designed as a replacement for your Telnet. Okay. The protocol specification distinguishes between two major versions referred to SSH version 1 and SSH version 2. Right now we are using SSH version 2 because it is more secure. Then SSH was designed as a replacement for Telnet for unsecured remote shell protocols. So if you want to secure remote access, then you can use the SSH. Now we'll see some features about your SSH, some key points. So your SSH is again application layer protocol, and it is used to connect an account on another remote machine in a secure way. Telnet, we are having the access, but not in a secure way. But in SSH, we are having the access in a secure way. Telnet uses port number 22 as 23, and SSH uses port number 22 by default. SSH port number you can change in your Linux systems. SSH work on TCP protocol, means we are having the acknowledgements. Okay. SSH uses encrypted format to send the data, and even that data is traveling in a secure channel. Okay, means you cannot intercept the SSH communication. We cannot see the data, and I'll show you that it will be just saying, okay, this is data is encrypted data. We cannot see like, okay, what is the usernames, what is the passwords? No. SSH help you overcome many security issues of Telnet, and almost all actually. SSH is a more secure protocol. It uses public key encryption. Okay, there is a asymmetric key encryption. Okay, in this asymmetric key encryption, there is a public key generated and a private key generated. The private key, the server is going to keep to itself. The public key, it is going to send to the client. Now, what is going to happen? The client is going to encrypt the traffic from the public key, and that particular traffic can only be decrypted by the private key that the server is having. Okay, and if server is encrypted traffic with the private key, it will only be encrypted with the public key. So means if anyone is trying to sniff this data in between, he is not getting anything. He will get the encrypted traffic, but he's not having the private key to decrypt the traffic. So he will not understand anything. Okay. Then your SSH require high bandwidth uses because there is an encryption mechanism and there is a secure channel. So it will be using more bandwidth, more data. And it is used in all popular operating systems. This is clear. If we go for the differences between the Telnet and SSH, so let's do the SSH practical first, and then we'll go for the differences. So remember, for SSH, you have to follow certain criteria. Like Telnet, we just go to the lines, configure the password or username, password, and it's done. But SSH is not like this. You have to follow certain criteria for the SSH. Okay. So first of all, let me remove the configuration of Telnet. So let me erase the startup config first, so that I'm not like it. I'll not be asked for the password. Or let's leave it. Go to the global configuration mode and say no username CCNA password Cisco, and I'll say line VTY021, and I'll say no login local. So configuration is removed. Now if I try to access, if I try to take the Telnet access, still open. How is this possible? Check the configuration again. Show running config. I'm not having an okay. Line 2 to 4, we are having the login command. Line VTY024, no login. Now let's try. By default 0 to 4. By default 0 to 4. That's why we are able to access. You see, we are able to access without even password. We didn't give any password and we were accessing. Okay, it was by default. So now if we try to access again, very strange. We are not having the configuration and still we are able to access. Show running configuration. IP addresses are there. No login command is there. Okay, let's do one thing. Let's use another router. This is some bug. Let me save this. Check the configuration in the router. 456. Show running configuration. No command. Try to access. Telnet 192.168.10.1. How is this possible? Let's use another router only. The default access should not be there. 10.0.0.1, and we are going to configure 10.0.0.2. Just a minute. Let me try one more thing. Line VTY0 to 15. No login. There is a problem only. Okay. 10.0.0.2. Interface is 0 by 0. IP address 10.0.0.1. 255.0.0.0. No shutdown. Okay. Now let's check if we are having default access. Oh, Telnet. By default, you will not be having the access. Okay. If you haven't configured the Telnet, you will not be having the access. So this is some kind of bug here. Okay. That is providing you the access without any configuration. Okay. Now we are going to configure SSH. So if you want to configure SSH, you have to follow certain criteria. Okay. What are the criteria? First of all, your host name should not be router. Means you should not have the default host name. This is the first criteria. So first thing we have to do is change the host name. Second thing, you have to set a domain name. You have to set a domain name on your router. Domain name like jic.com, or you can say nh.com. Okay. Any domain name should be there. Then the third thing, you have to generate the encryption keys. Okay. So the encryption keys are RSA encryption keys. Means the public private keys we are talking about. We have to generate these keys. Then the fourth thing, you have to create username and password. And finally, you have to configure VTY lines. So these are the 5 conditions for your SSH. And you have to follow these 5 conditions. So let's go for them one by one. So first of all, I want to change the host name. So I'll give the command host name. Let's say I'll give SSH. Any name you can give, that is your choice. Then we have to provide the domain name. I'll say IP domain name. Okay. And any name you can provide. Let's say I'm saying nh.com. Okay. Then we have to create the RSA keys. So RSA keys you can create with the command crypto key generate RSA. Okay. Hit enter. So the RSA keys encryption range varies from 360 to 2048. Okay, this is basically, you can see like in websites, certain websites you might have seen like this website is secured with a 128-bit encryption, 256-bit encryption. So what does it mean basically? Let's say I'm using for SSH, we require at least 768-bit encryption. Okay, so let's say you are using 768-bit encryption. So that means if someone has to break your password, then the possibilities of the password are 2 raised to power 768. 2 raised to power 768. Even 2 raised to power 128 addresses we are having in IPv6, and we say they are in unlimited address. We are saying they are unlimited address. So you can imagine the value 768. Means even supercomputers, they need some time to, right? And if you use 1024 or 2048, the highest level of encryption, then it is totally secure, unbreakable. Even your supercomputers will not be able to break this. Clear? So at least you have to use 768, or you can go for the 2048, that is the highest, or you can generally, right now popular uses 1024. Okay, so right now I'm just using because this is a small network and we are not having a lot of traffic. Because the higher encryption you used, if you use more, the higher bits of encryption, what is going to happen? Your router has to use more CPU to create the encryption, to decrypt the packets, for all those things. Okay. So this is going to take more of your CPU. So that's the reason that you use from the 768, either 768, 1024, depending, because your SSH uses a bandwidth. Clear? Because but right now we are doing it in packet research, so no issues. We can do it. Okay, 2048-bit encryption we have taken. Okay, so third step is done. Create a username and password, and if you see here, SSH version 2. 1.99 is 2 already. Okay, so SSH version 2 has been enabled. Now you have to create a username. So I'll say username and let's say Cisco, and password, let's say CCNA. Done. Then configure the lines. So line VTY 021 and just say login local. That's it. This is the complete configuration for your SSH. Okay. Now go to the system and take the access. But right now, once you give the line VTY 021 and login local command, your telnet and SSH both are enabled. You can have the access through the telnet also. Login invalid. What was the password? Was it capital or small? Capital. Oh, capital. So username is Cisco, password is CCNA. We have the access, but this is telnet. Now, if you want to access with the SSH, you have to say SSH-L. Then you have to give the username Cisco and the IP address 10001. Hit enter. Asking for the password. Give the password. Hit enter. You get the access. Okay. But let's say you just want to enable SSH only. You don't want telnet. So you have to go to the router, and in the line VTY 021, you have to give one more command, that is transport input SSH. Means only SSH will be allowed, rest not allowed. Now if I try to access through the telnet, if I try to access through the telnet, I'm not able to access. But if I try to access with the SSH, I'm able to access. Okay. This is clear. Now, if you want to see whether it is secure or not, so go to the simulation mode. And this time, instead of Telnet, we will be capturing SSH. Go to the PC and give the command. Okay, let me generate some packets. So these are some SSH packets. If we try to open these packets, go to the inbound PDU details. And if you go in the data, SSH data, what it is saying, encrypted data. None of the packets will be able to read. All data is encrypted. Okay, so this is why your SSH is secure. Is it clear? So differences between your Telnet and SSH. Your Telnet, it is highly secure, and your SSH, it is highly secure. Your Telnet, it is less secure. SSH port number 22, port number 23. Your SSH send all data in encrypted format. It is in plain text. Then SSH uses public key encryption, and there is no authentication mechanism. Then username and password can be prone to malicious attack. These are like this. Okay, this is by mistake on SSH side. This is about Telnet, because in case of Telnet, username and password can be easily taken. But in case of SSH, data sent using this protocol cannot be easily interpreted by the hackers. Why? It is encrypted. Then your SSH, it is suitable for public networks and Telnet for private networks. Then SSH can be considered as a replacement of Telnet since has overcome many security issues of Telnet. But about your Telnet, older than SSH and many problems, many vulnerabilities. High bandwidth uses in case of SSH, low bandwidth uses in case of Telnet. In all operating system, it is used, and it is mainly used in the Linux and Windows. And these are the RFC values. Okay, RFC is what? Request for comment. These are the documents in which these protocols are defined. Okay, if you want to read very detail of these protocols, you can refer to these RFCs. So they'll give you from start to end everything about this. Like for SSH protocol, you'll have like 10 pages of information, 20 pages of information, like this. Okay, so like if you want to check SSH RFC 4253, just go to the Google and say like RFC 4253. Do you see? Okay, so this is, and you can refer to this website. This is actually handling all the RFCs, IETF, Internet Engineering Task Force. And you'll see, you'll have all the details. So you see how many pages are there? 31 pages just for the SSH protocol. Okay, what are the encryption, hashing mechanisms, and how it is working? Everything is there in this. Clear? So this is all about your Telnet and SSH. Any doubt with this thing? No? Online people, if you want to have the comments for Telnet and SSH, let me give the comments. Okay, so how you are going to configure Telnet? Just for the password access, you can say line VTY 0 to 1. Okay, let me directly give comments. Then you can say password and whatever password you want to provide. For example, 123, and you can say login. That's it. Okay. Telnet access using username and password. So using username and password, if you want to have the Telnet access, you can give the command in the global configuration mode, username. Then you can go for the line VTY 0 to 1, and you can say login. This is your Telnet configuration. For SSH, okay, we have certain criteria. What are the criteria? First of all, you need to change hostname. Second, create a domain name or configure a domain name. After domain name, you have to give the encryption keys. Then create username and password. And then configure VTY lines. Okay. So if you want to see the configuration, sample configuration, you can say hostname R1. Then for domain name, you can say IP domain name and any domain name, let's say ns.com. Then RSA keys, you can say crypto key generate RSA, and you can give the encryption keys. Then you can say username, again Cisco, password CCNA. Then you can go for line VTY 021 and say login local. This is SSH configuration. And this is your Telnet configuration. Clear? Any doubt? Online people, any doubt? Okay, then I'm done for the day. We'll meet tomorrow. Have a good day, guys.